Alright, you've been factorising recently, and I promised you that that was useful, it wasn't just some arbitrary stuff. So we're going to solve some equations by factorising. I'm not going to show you how to factorise in this video because you've got the other one, so there are going to be things that appear factorised here. So, I want you to first think about this equation here. A lots of b is 0. And you should know something about what a or b might be to get 0. What things can multiply to get 0? The only way to get 0 multiplication is if one of these things is 0. So this equation is only true if a equals 0 or b equals 0. There are two times this equation is true. 0 times anything is 0, or anything times 0 is 0. And this equaling 0 from a pair of factors is fundamental to how this works. And because those are factors, that's where the factorising comes in. So here is an equation in A that's already been factorised. Because as I say, I'm skipping that section. So you would factorise it to get in this form. And that means either this first factor here equals 0, or this second factor here equals 0. Now in the first factor, we have got a plus 3 equals 0, and you should be able to work out by subtracting 3 from both sides that that means a is negative 3. And in a similar way, we get a take 7 is 0 from the second factor. Well, something take away 7 is 0, it's 7. So our answer to this equation would be a equals negative 3 or positive 7. There are two solutions to a quadratic oftentimes. We'll show you why at some points, linking to other bits of maths we've done. But crucially, when you get the factors, you set each one equal to 0 so that you can solve it. Equaling 0 is important. If it doesn't equal 0, you can't do this whole piece of work. Alright, so you will notice a pretty straightforward link between that value and this value. And between that value and this value. They're simply a change of signs. Pardon me. So, positive becomes negative, negative becomes positive. That's going to be true all the time because of this solution of inverse operations. So we can do that very quickly. We get b equals negative 1 or positive 4 just by changing the signs of each one. That's a pretty useful shortcut, although this really is what's happening behind the scenes. This is useful to remember because if the factors get complicated like this, you might need to find them yourself. So again, we set up the equation 3c take 1 equals 0. This should take 2 steps if you're doing it thoroughly. We add 1 to both sides to get 3c is 1. We divide by 3 to get c is a third. Or the other bracket, 5c plus 7 is 0. We take 7 off both sides to get 5c is negative 7. We divide by 5 to get c is negative 7/5, which you can convert to decimal if you're one of those people, but I like leaving it as a mixed number. You might want to think about, is there a shortcut to get from here to there or here to there? It will save you time at A level, but it's not essential that you have that now. This method is what's expected. I want to highlight again the importance of being equal to 0 before you factorise it. So if you get an equation that's not equal to 0, you'll need to do some rearranging first, then factorise, and then use this technique. And if the factors are easy, it'll come out quite quickly, just with this simple changing signs in and out of the bracket. Here there is some simple changing of stuff, but I'll let you work that out for yourself, and hopefully some of you will respond and reply with how to do that. Good luck with this.